There you go. When you get here, we'll be waiting. Toulouse à tout.
Le soir obscurcit la pelouse. Pour l'oiseau, laissons les gâteaux secs. C'est parfait, on repart à Toulouse. Lautrec.
I'm going to call up people. Ladies and gentlemen, we are going to start again the panel 5 for the ICT for Railways 2021. If you want to go home early today, please join in.
Before the introduction of
Toulouse a une spécificité dans ses rapports à l'autre, c'est pas compliqué. C'est brut de décoffrage, quoi. C'est aussi puissant que son accent. Pour moi, ça incarne la ruralité avec toute sa beauté, toute son authenticité. Toulouse est une ville à la campagne. C'est très fort, c'est très présent dans Toulouse, cette campagne environnante qui pénètre dans la ville. Par plusieurs moyens, par les bois qui entourent la ville, mais aussi par les réseaux fluviaux. On a la Garonne, bien sûr, il y a le canal de Midi, on a le canal de Brienne, toutes ces voies d'eau qui font que la ville respire, elle est comme irriguée. Midi-Pyrénées est un grenier immense et Toulouse en est un peu la vitrine. Pour moi, restaurateur, c'est un terrain de jeu fabuleux finalement. J'ai pas besoin d'aller très très loin, j'ai tout sur place. On a la truffe, on a le foie gras, on a la laiton de l'Aveyron, tous ces produits on les trouve ici. Ils viennent, ils arrivent naturellement. Et Toulouse est une vraie porte d'entrée sur de nombreux territoires. D'un point de vue architectural, le Capitole, c'est fort, c'est emblématique, c'est la mairie, mais c'est un peu le joyau aussi de la ville. Quand le soleil vient lécher la façade du Capitole, qui est tournée vers l'ouest, il y a ce rose qui devient évident. On est dans la ville rose. Sincèrement, c'est impressionnant, c'est majestueux. Il y a des lieux qui sont vraiment très forts. Moi, le cloître des Jacobins, bien sûr, c'est un cloître et il y a un magnifique festival de piano, la piano jacobin, c'est magistral. Mais Toulouse a aussi une spécificité, elle a plein d'hôtels particuliers avec des cours intérieures. Il y a l'hôtel d'Acésa, qui est un des plus beaux, des plus connus, mais il y en a une cinquantaine, je crois. Aujourd'hui, la force de Toulouse, c'est une force, c'est cette industrie qui est un des joyaux de l'industrie européenne, c'est Airbus. Pour moi, c'est le poumon de la ville, Airbus. Quand on est adopté par la ville, on doit adopter le rugby. Quand Toulouse gagne un bouclier de Brennus, c'est, même s'ils en ont gagné des dizaines, j'ai envie de dire, c'est un événement important. Et quand les joueurs, en place du Capitole, brandissent le Brennus, c'est toute la ville qui est présente. Et franchement, moi, ça continue à me filer la chair de poule. C'est une telle fierté. C'est un vrai besoin de faire la fête ici. C'est un vrai besoin de sortir, de se retrouver autour de quelques tapas avec un petit verre de fronton. La nuit passe et il fait beau. À Toulouse, il y a toujours eu une école autour de la musique et du chant. C'est très présent. L'orchestre du Capitole, ça fait partie des richesses de la ville. C'est un orchestre qui brille depuis des années. Aujourd'hui, on a la chance d'avoir un chef comme Tougan Sokiev, qui est un jeune chef extrêmement prestigieux et brillant. Finalement, c'est une ville où on vit sereinement, on y mange bien, on s'amuse, on fait la fête, on écoute la musique. C'est ça, Toulouse.
So in the afternoon, we'll keep going with the panel number 5 for the new products and the new services. And today the topic will be about aerospace and railway synergies, train localization systems, SIL4 computers, safety concerns, onboard Wi-Fi and wayside Wi-Fi, as well as innovations for the rapid prototyping to serial products. And this is Halle de la Machine in Toulouse. If you want to see something big, you can go and visit them. This is the museum, which is just next to the airport, 2 minutes from here. This is going to be for the summertime. Ladies and gentlemen, we are going to be starting now. So that's going to be finished about the presentations and the videos. So let's start again the panel 5. Ladies and gentlemen, please, we are just waiting for the last people who are going to enter the conference center. And for the panel 5, new products and services. So this morning we had a very nice presentation from Ferro Campus about artificial intelligence and the trusted eye, as well with Leroy Automation about safe computing solutions, where they discuss the subjects about cyber and safety concepts. This afternoon we are going to enter presentations about the synergies between the aerospace and the railway sector. So I would like to call to the stage Mr. Didier Rigal. So Mr. Didier Rigal is part of the IRT, so which is like a research center linked to Saint-Exupéry in Toulouse. I will let you to introduce yourself.
Thank you.
And then the floor is yours. Thank you.
Thank you very much for your introduction, and thank you for hosting us today. I do represent the Institute of Research and Technology of Saint-Exupéry, an institute which is focusing on aeronautics, space, and critical systems. And today I will briefly introduce to you what are the competencies that we are developing and in which way we do transversely address the subjects of the space industry, of the aeronautics, and of the transport, and what kind of synergies can be settled between the different domains. A brief overview of my parcours, which is to say that I'm a pure aerospace man, having spent my entire life into Airbus, Telespazio, and then Thales Alenia Space, and I joined Institute of Research and Technology this summer, quite recently, to animate the development, the business development of those institutes, and the development of the platforms that are used in the diverse domain of competencies. Next slide, please. So in terms of footprint, ERT are numerous in France. We have about 16 ERT covering various domains. Of course, we are each of them specialized in different topics. We, ERT Saint-Exupéry, have different interactions with the other one in the domain of telecommunication, in the domain of artificial intelligence, in the domain of materials, mainly. And we do develop joint projects transversely, particularly in the domain of artificial intelligence, where we have common and transverse projects, and also material. Next slide, please. So we do cover a wide range of activities. One of the particularity of the ERTs are that they are focusing on project developments. And as you might know, we do promote projects where we can provide co-financing from the PIA, Plan Industriel d'Avenir, and by developing those projects, we also have another particularity, which is to associate the academics world with the industry. And as you see in our people shaping, we have about 376 people working within the IRT Saint-Exupéry, among which about 170 are from the industry. And this is a richness that we do develop, which is very specific to this mechanism of development, and providing a lot of transversalities between the industry, the way of working and developing the program and the engineering globally in this domain with the academic components and the fundamental research. So this is really something on which we do capitalize. We are yielding quite a high number of PhDs, publications also. You see about 172 publications since the ERT was created. And an activity which is today in the domain, in the range of 40 million euro, I would say. This year it will be almost 40 million euro. And in terms of sites, we have 4 sites in France, one in Sophia Antipolis, one in Montpellier, one in Toulouse, the B612, the B6612. If you don't know the place, it's a big building close to La Beige, where we have about 10,000 square meters of platforms, and also quite a big site in Bordeaux. And last but not least, we have also a site in Quebec now, in which we do develop artificial intelligence. Next slide, please. So in the domain for which we are sharing today, transfer vision of contributions through different sectors, we have an internal program that we develop which purpose is really to animate and develop the transversalities of technologies, and particularly to synchronize different sectors in the mobility domain, and with the preoccupation of bringing green technologies, I would say, particularly in the domain of aerospace, where electricity was not at the core of the propulsion, for instance, but also to accelerate the research on a transverse way, for instance, in the domain of artificial intelligence. Of course, we have dealt with the fundamentals in the mathematics domain, but also we do implement program for applications in the critical systems for aerospace, for the space industry, but also for the train, for the automotive system, even in the domain of healthcare and robotics. We have activities in that domain. And we do develop and optimize platforms and competencies to enlarge the overlap and bring a broad picture transversely. Next slide, please. So in terms of footprint, we do have 12 competence centers that are distributed on 4 technological axes. What we do call green technologies refers to everything linked to the high voltage energy, the reliability on the energy domain, and also the density. So of course we have that kind of applications, a lot of subjects related to the management of the different voltages and the critical issues that this is yielding into a plane, into a train, into an automotive system. We do address subjects like transfer from SiC components, grand gap components, to GaN components, nitride of gallium components, to provide a more efficient system for the conversion of energy. In the advanced manufacturing domain, we do have 3 competence centers in the metallic materials, composite materials, and surfaces and assemblies methodologies and processing, which is also quite intensively used in the aircraft, but not only, intensively also in other domains. Particularly bringing new functionalities to the material, incorporating sensors, incorporating different means of communications, the possibilities to integrate antennas into the material itself. It's a domain in which we have a lot of transversality. In the smart technologies, of course, covers everything related to artificial intelligence for critical systems, a lot of things in the domain of artificial intelligence for embarkability, so what is the predictability and the capacity to trust artificial intelligence. Also a lot of things in the domain of machine learning, reinforced learning, and autonomy and connectivity. And last but not least, the method and tools for development of complex systems is an axis in which we do develop system engineering methodologies for multiple discipline optimization, and particularly for critical embedded systems. Next slide, please. So I will fly over some examples that correspond to the equipments and the laboratories that we have in the different domain to illustrate the transversality. In the domain of high voltage energy, as we see here we have, of course, different laboratory to test and develop different material, optimizing the partial discharge phenomena, and it can be used, of course, for the different network and of transport of energy into a plane, into a train, into an automotive system. But it is also usable for the space industry. In that case, it's typically kind of modelization capability of the arc that came from the transport sector and that is now valorized into the space domain. And also a lot of things into the aging domain. Analysis of aging of the different materials submitted to different partial discharges into different environments. Next slide, please. In the domain of reliability, I was saying before that we perform a lot of things in the GaN domain. The nitro gallium technologies are more and more used and usable into the energy conversion systems. Of course, you know that there is a problem with SiC components availability currently, so it's important to find alternatives. And more broadly, it's also something which is bringing flexibility and competitiveness into all the domains. So we have a lot of projects in that domain to develop not only testing benchmark, but also the capacity to anticipate what are the reliability and the performances of those systems into different environments from space to ground. Next slide, please. On the metallic material and processes and assemblies domain, the ERT is quite well equipped with different processing units for different material, and the composite particularly. You see it on the picture here. Currently, there was a lot of work conducted in the domain of functionalization, so bringing new features to the materials to serve the applications with specific functionalities, like the antenna development embedded into the material, for instance. And this is applicable to transport, to plane, and also to space, I can tell you. So it's quite an active domain in which ERT is playing a key role. Next slide, please. Artificial intelligence domain is one of the foundation layer, I would say, of ERT Saint-Exupéry. The first topic and the first focus was on the explainable, certifiable, frugal learning. So the capacity of artificial intelligence to be used into an embarked and critical system. So we don't allocate the decision to pigeons, as I said this morning, but in some cases you have to know what is behind the neural network that you are using, and in which way it can potentially provide answers that are not necessary into the domain of flight of the system. So we have done a lot of things with low TRL levels on the mathematical part of this to explain the way the neural network are working, the way they are developed, the way they are maintained, and they do evolve. And we continue to work on this domain quite intensively in collaboration with ICT, and we have also a lot of collaboration with Systemix and Saclay IRT also in the domain, with Jules Verne also, and now in Quebec. In Quebec, we have a small team that is that was settled just before the COVID. So, of course, during the COVID period, it was not very active in terms of development, but now it is raising up again, and it's a place where there are amazing competencies and partnership to be developed jointly with about 70 people that we have in Toulouse working in that domain. Important to say also that artificial intelligence is not only for artificial intelligence, it's also serving the needs of the energy transport assessment or the material design. So we have now since several months, I would say, developed a lot of more transversality, I would say, between the different technological domains by themselves. To have the capacity to use also those methodologies for the design phases of the systems. And this is bringing us on the next slide to the last domain of competencies, which is the multiple discipline optimization. Domain which is not very much developed in France, but which is now starting to take more and more importance, because it's core for competitivity, and we have developed into IRT an amazing processing suite which is called GEMCO in Python, which is allowing to address any engineering issue with the capacity to optimize the design with those MDA methodologies. And I can tell you that we have applied those tools for very different applications, like, of course, concept of material, but also a resolution of a complex system like a wing system for an aeroplane, or a specific design for a model of climate. And it's amazing the capacity of those methodologies to solve very complex equations. I think I do cover the entire scope here. Of course, I cannot enter into detailed explanation of the reusability, but I hope that I have exposed to you all the potentials and synergies that we can bring along with those competencies, 12 competencies center and 4 axes of technology. And you are all invited to address IRT, Saint-Exupéry, in Toulouse or in the other places, to work jointly with you, develop projects with you, using or not using the PAA co-funding. We have the capacity to address your needs with solutions. Thank you for your time.
Well, thank you again, Didier, for your nice presentation from the IRT. And well, maybe a quick question is, like, I've heard often that the aircraft and the aerospace industry is much way in advance compared to the railway industry. Is that really true?
Not in all domains, I wouldn't say so, but we are. It is more advanced. Some specific critical issues related to the aerospace. For instance, in the material domain, there is, of course, a weight equation to be solved for a plane that maybe you don't have immediately to solve for a train or an automotive system. But the technologies that we are developing are reusable fully, and I am myself, coming from the aerospace industry, amazed with the number of transversalities that I do discover within IRT and the technologies that we have developed.
Well, thank you very much again, Didier, for this clarification. And well, thanks again for the nice presentation. And now we are going to proceed to the next one. We've heard that all railway operators have sometimes some issues to know where their trains are, on the tracks, of course, but where are they located? So this is a nice presentation going to be demonstrated and explained by Mrs. Sophie Glevarek from the company X-Blue, specialized in hybrid localization services and systems.
Hello everybody, so I am a technical engineer and in charge of developing the inertial navigation system for railway for X-Blue, my company. In fact, we are part of many domains of application with our inertial navigation system, and we have many questions of how to help railway undertakings and to reduce infrastructure, cost and maintenance with the new technology we promote, which is hybridization with our INS, with GNSS and other parts of new technology. Next slide, please. So a short brief overview of the company. We have an headquarters of Saint-Germain-en-Laye, which is near Paris. And in fact, we are more than 20 years in navigation system with many domains of application. And we are part of railway application for mainly, mobile mapping, maintenance, meteorology system or ground truth with our INS, and now we are think about to use it with direct navigation and to bring a good break of localization system. So we are on a project as Anan Aitnoun present this morning, up to 2 years ago with SNCF on that. So next slide, please. Yes, thank you. So what is a INS? Inertial navigation system is based on, in fact, on 6 degrees of freedom, 3 accelerometers, and 3 rotation made by gyrometers. The gyrometers we built in X-Blue is based on fiber optic gyrometers. And with this IMU, of course, this is not enough for navigation. We have had to add a navigation system, robust algorithms dedicated for providing high rate and low latency, because it's complete in the same solid, 3D position, georeferencing position, and also speed. So all of this could be provided for a good localization position on board on the rail. The plus of this technology is that it is fully embedded inside the vehicle, so it knows very well all the orientation of the vehicle and all the speed and all the motion of the vehicle. So this helps us, in fact, to put many algorithms, and some algorithms dedicated with this kind of vehicle, which is a train, because it's a one-guided vehicle. So we develop also as well some dynamic models specific for the train. So this is part of the INS. Of course, the capability of the algorithms we have is possible to hybrid it with external sensor, because of course nobody is perfect, so this system is drifting a little, and then we have to fix sometimes position, and we can be helped by that with the GNSS, so by the satellites, and also by the cartography, which is not environment dependent, different of the GNSS. So this is the purpose of the presentation is to present you the results you have with this hybridization on the INS, with the hybridization of GNSS parts, and also with the cartography we work with SNCF right now. Okay, so just a short brief, an overview of the internal system embedded. In fact, we do not only deliver IMU and navigation unit. We deliver, in fact, a kind of fusion algorithms with all of these external sensor. In fact, it is specific filters in which you have IMU sensor, internal sensor we manufacture, like accelerometers and gyrometers. And in the other side, the external sensor could be used on GNSS, map, etc. So all of these are well balanced with a complete error model of the system. So we manage this as well in order to deliver INS data at the output, and also for sure the standard deviation, which is a statistical error view, which must be covering and precise as well for having a good error at the end. So this is this technology, in fact, what we will see after the results we have, it's 100% available data, because at each time 100 Hz or 200 Hz, they deliver position and speed at each time with a full availability. Okay, next slide, please. Okay, a short brief of the kind of technology, in fact, we use. We use here gyrometers by fiber optics. In fact, at XBlue, we are found technology, but we are also a manufacturer. We manage as well from the beginning of fiber optics. Fiber we manufacture to make the coils and then to make the gyrometers. So we have a photonics division up to final integration and qualification. This is the same with accelerometers. We develop the wafer, we implement it, and we make the MEMS accelerometers. So we make all the IMU sensor in our plant, and we also develop all the algorithms in order to have a complete control from A to Z of the system. So here there is some pictures of the photos we have at Brittany in Lannion, in fact, and the plant. One people is going to make a coil here. Checking a coil or a wafer for an accelerometer, in fact. Next slide, please. Thank you. So, what is the purpose right now? It's a test we carried out with SNCF. In fact, we are part, and we have leader, in fact, of the project Log4Rail. Will be ended at the end of next year. And we develop for that a rack in which there is one of our INS. In this rack there is an embedded PC capable to register the data, check it, and after send it via 4G link to a data server, in which we can then at lab have the time to analyze the data and explore it. So this rack is fully certified for railway application, and we already installed 4 of them. 2 are installed in area line C and line D right now, and TGV. So right now we are up to 20 kilometers and more than 2,000 hours of data register. So it's a quite big data, and we work also on that to make automatic tests because it's quite a big data analysis of this, and we have again 1 year more to test, so it's huge data to collect and to analyze and to make some automatic analysis. So next slide, please. So what is the results? The result I presented is hybridation with GNSS and hybridation with cartography. Here, in fact, we have a test not very helpful for GNSS because it's a suburb of Paris and Paris, Intramuros. It's area line C. So it's very, we note that the GNSS in that part is very masking area because of tunnel, because everything. So roughly there are less than 60% of availability of this sensor. So for sure, what we see in red, this is a GNSS, and what you see in blue, this is a INS, complete final solution. So for that solution, for sure, we have 100% available in performance. In fact, we have also on this curve, you see, we obtain better than 10 meters at about more than 95% of data collected. So it's very relevant for SNCF at this stage for a non-safety use. So it's very interesting and impressive at that stage right now. Of course, we obtain this result because we have good algorithms inside and we have a dynamic model vehicle inside which help the performance. So of course this is the first result. We have hybridization with GNSS, but we can do more in fact, and we develop and we have a patent on it with cartography hybridization. So in the next slide you see the same kind of surround environment, which is area line C already. And the concept here is that we know the cartography, so we know the line of the train, and then we can analyze it and put some kind of virtual balises, but we can some fixed position at a located georeferencing point, very interesting, which is a point of interest for the inertial sensor detection. And once we put this point of the map, we have another map with this point, georeferencing point for INS, and we send it to the INS, and then we can carry out the line. And at each point, the system is encounters this fixed point. It can take that as it was for a fixed point external system. And then you can see in the blue line the results we have for the run, which is very interesting at that stage also. We have again 100% high performance fully available with less than 1 meter horizontal RMS value. And you see in one another thing it's interesting is that in green you see the standard deviation, and you can see that it's 1 sigma, and you can see that it's always covering the error, which is very also interesting, and the robustness of the algorithms embedded demonstration. Upper you have the speed, because another part of the INS which could be very interesting is the speeds that generated, and you see the speed of the vehicle here. It's RER, so yeah, there is many stops, and the level of speed also could be useful for the localization for sure. Okay, the last slide is the same picture with hybridization with cartography, but the first result we have on TGV. TGV, it's also very interesting to explore, because there is a high, of course, high level of speed and low level, and the trajectory is very specific. So you see in the speed here up to 300 kilometers per hour, and all during the trajectory, and the speed profile, which is very interesting for us. And at the bottom, the results we have with the same hybridization with the cartography, which is quite interesting also. We have roughly RMS of 5 meters horizontal position, so it's quite interesting also, this one. Okay, so this is the end of my presentation. Thank you. The next step for us is to collect again and again data, and to again and again have a rough and very important statistical analysis in order to demonstrate that the system is totally robust to the concept for the localization without many infrastructure, in fact. And the next step after is to transfer that on a safety purpose still for implementation. Thank you.
Well, thank you very much, Sophie, for this nice presentation. So maybe may I call for a question from the assembly here? Well, I'll just get one question from the YouTube platform, because this is a live streaming as well on the YouTube. And the question is about the localization system here. Would it be able to replace all the equipment on board a train, actually on the actual train, like the speed sensors, like the radar systems, in order to find the exact localization of trains and to improve the number of trains traffic on the line.
Yes, this is one of the objectives, for sure. But we know that we are an industrial, and we know that the step is quite long to have the level of safety expected for this. So, but the proof of concept and the demonstration of performance we have right now is very interesting, and we are on the good direction.
And this is a great example where the aircraft, military, and space industries are at the service of the railway industry for the next generation of signaling systems. Then, thank you again. So this gives us a link to the next presentation, because we need safety for all of this in the future. So we'll call Mr. Sébastien Agostini from the company ClearC, specialized in safety systems and vital solutions.
Hello. So good morning to everyone. Thank you to Sebastian.
This is the afternoon, in fact.
Good afternoon, so. Sorry about that. So thank you. I'm pleased to have the opportunity to introduce ClearC and the ClearC safety platform, the safe calculator we develop, and myself too. So my name is Sébastien Agostini. I'm business unit manager for the electronic and embedded system department in ClearC. So for beginning, maybe a few words about ClearC. We are a design office, a French company specialized in safety critical system and in design safety solution. We are the author of the formal method Atelier B. Just few words about the formal method. It's a way to mathematically prove software compliance against the specification. And we work worldwide. 20% of our turnover is abroad, but always with safety matter. So today I introduce, as I said, the ClearC safety platform, which is a package, and it's a Seal4 system, including the calculator, so in terms of hardware, of course, the calculator, and a starter kit in order to implement it for prototyping purpose. We also included software, the firmware and the safety firmware of the calculator in order to ensure that all the execution is made in a safe way. And we also propose all the tool chain to integrate the environment and the necessary tool to load, compile, and so on the calculator, the final application. And of course, the safety case, because it's a Seal4 system already certified, ready to market, with all the guidelines to implement it in safety. So why we propose this kind of system is because we already implement that kind of architecture on past projects. So I have some example here with the control command screen doors for Sao Paulo and Stockholm, which implement that architecture. And more recently, for remote I/O, an interface with CBTC, that have the particularity to be compliant with the Senelec standard, of course, so EN 50, 128, 126, 129, but also with the AREMA standard, which is the equivalent in North America. So in terms of hardware, it's a Seal4 component ready to integrate on the design. As you can see, it's a compact size required to be integrated on the motherboard. It's a versatile product because all the peripheral of the microcontroller is available on the connector, and so it's up to the final user to develop the peripheral and the interface to be fully compliant with the project and with the requirements of it. And of course, it's low consumption. It's based on true microcontroller from microchips, so it's less than 2 watts, and it's based on a 2 out of 2 architecture in terms of hardware. We associate it to a starter kit, a jumpstart system to make the prototyping easier and to implement some proof of concept based on this calculator. So we propose all the toolchain to be complied with and to help to develop this product. And so we integrate also on this starter kit the interface, the standard interface like I/O logic, serial communication, Ethernet, and so on, USB, all that can be used to develop prototype. In terms of software, we also develop a basic firmware to be integrated on the low level of the hardware with some primitive to be called for safety purpose and for final application purpose. Already installed on the calculator. And in terms of development, you have at the top level the specification in native language, which has to be implemented in B0, which is a subset of the B language, formal language. So after the specification, you have the implementation of the source code, one unique source code, and 2 channels of compilation for diversification and for safety purpose, to have at the end of the compilation a concatenation of what we call the 2 replicate, which is 2 different binary from the same source code but with the same behavior. And so when you download these 2 replicate on the microcontroller, based on the fact that they have the same input and they have the same behavior, we are able to check at each cycle that there is the same output from the 2 replicate, and so ensure the safety of the execution. So it's a composite safety execution with 2 out of 2 per microcontroller execution of the software. Okay, next please. So we have also the toolchain, as I said, because for safety purpose, of course, all the tools for compilation, downloading, and so on have to comply with all the Senelec standard and all the safety purpose. And so we aggregate all these items in a tool, completely hidden by the end user to make it easier for them to, they have only to compile the system and to obtain all the binary file ready to download on it. And so all the primitive are completely hidden to the end user, and they are only to start a command. Today the input of the implementation is the B language, so B0 here, which is a subset of the B language, really comparable to C or ADA, but there are various strategy to implement it in the B language. You can write manually, you can generate it in order to to have the benefit of all the formal language in terms of validation, in terms of mathematical proof of the software. But you also can use past source code in another language, for example C, ADA, or something other, and have the capability to translate it in B language to have the right input of the toolchain. Okay. So how can it work? If you have a project, if you have an implementation to be done, the first step is to design the interface in terms of hardware. I mean that kind of calculator have to be docked or to be fit on a motherboard, and so all the specific interface have to be designed to be compliant with the project and its interface. So in terms of hardware, we need a motherboard. In terms of software, of course, the basic safety firmware is already available on the calculator, but you have to implement the final logic, the final application of the software on the calculator in B0. And at the end, you have to write and to demonstrate the safety by a safety case. So there is some item to comply with. First of all, you have the certificate, the SIL4 certificate of the calculator. You have to comply with the safety application condition of this calculator to be SIL4. And to help you on do that, we made some guideline and checklist to make certification easier. Okay. So I will introduce an alternate solution to localization, which use that kind of safety platform. It's based on two equipment on board. I mean a sensor and a control unit. And it also includes a magnetic loop on the way side. So this magnetic loop is in fact a very long antenna, 300-meter antenna, all around the track, between the track. And this antenna includes two different magnetic loops. That's schematic here on the picture in the middle. So you can see here that there is a blue one, an irregular magnetic loop here that allows to communicate with the train and to send him some identification. It's a kind of barcode for the train to identify on which antenna and on which sector of this antenna the train is. It's a kind of large localization. And based on this first point, the train can be localized precisely by the second magnetic loop, which is red here in the picture, and that allows to the train to count every regular edge of the magnetic loop to have a better accuracy, because between each edge there is 20 centimeters, and the train can see each edge and to see where it is in the magnetic loop. So it's okay. So the safety is only based on these three aspects with the automatic test and the two magnetic loop to communicate with. Thank you. In terms of hardware, you have here an example of the motherboard, so where we can see that there is the Clear safety platform on the left in blue, and there is two independent channels connected to this calculator for sensor the magnetic field. And this redundancy is for safety for sure, but it's also because we need to test regularly that kind of channel, and so there is a combination of two channels twice, because when you test a two channel we can count on the previous one and make an inversion to test the other channel. So it's a redundance for safety, but there is a double redundance to allow to test each channel. And at the end of the day, with this application, based on the SIL4 certificate of the calculator, based on the hardware we designed, and also based on the formal mathematical proof we have on the software and on the system at system level, we can have the demonstration that the train can give its localization precisely with tolerance, of course, based on the worst case of failure and based on the 20 centimeters between each edge, but a SIL4 localization for the train and the speed of the train. As a conclusion for the safety and regarding the Clear safety platform, we propose today a safe calculator ready to market, which include all the safety requirements in terms of software, in terms of hardware, to develop turnkey application ready and really specified to the project. Of course, there is a work to adapt the interface on the motherboard, and of course there is the final application software to implement on it. But it is based on mathematical proof, and based on this fact, we can make the development, the certification shortly and easier. And based on the strength of formal method, we can also save time for validation, because the mathematical proof make the validation, the unitary test, easier and simpler to be more efficient in the SIL4 system development.
Well, thank you again, Sebastian, for this presentation about safety and seal for context and solutions. May I call for a few questions from the audience here? So no questions from the YouTube this time, but I may have a question,
Yes,
frankly
of course.
speaking. We have discussed before localization through one technology based on inertial systems and hybrid systems. And then on your case, you offer something completely different with a magnetic interface. So is this going to be patented, or is this a patented solution yet?
The patent is only on the Clearsea safety platform, on the computer and computing unit today, but not on this solution.
Well, and does it mean that if I want to localize a train with your systems, you can offer hardware platforms ready to use off the shelf, as well as a safety certificate to accelerate my development in terms of software?
Of course, we have already certified hardware by the Safe Calculator, ready to market, and of course I can help you to do your development on it. Regarding the solution of localization, it always required an adaptation to the train, of course, and to the environment to be comply with all the safety purpose and the environmental purpose.
Okay, well, thank you again for these nice explanations as well. And so this is going to lead us to the next presentation from Mr. Christophe Barnier from the company Erasme, specialist in safety and certifications.
Hello, good afternoon. I'm Christophe Barnier, I'm technical director of Erasme, and I'm working in safety embedded system of software and system and hardware for about 30 years. Erasme is a small company which perform RAMS analysis, which is safety, availability, reliability, and maintainability analysis. And we support company to build their safety demonstration, and we support the company till the certification of our products. So next, since many years, the accident rate of different in the railway, in the European railway, the accident rate is decreasing, and we, thanks to the use of electronic devices and some monitoring system that are implemented in the different locomotive or so rail track and so on. So what's the effect of this system is that we need context and standards to use it safely, and then we have now a lot of standards that mainly are presented to system, hardware, and software. So the three main standards are the 5126, 5129, and 5128. So one is dedicated to RAMS analysis, and the other one to hardware, and the third one to software. What is specific to this standards is that the 5128 for software is it relies more on the control of the process of the production of the software, and so the verification and the test strategy and the elaboration of the documentation. And the 5129 is more dedicated on the mastering of the random failure, that the hardware, the component hardware can bring to the board or the system of signaling of the embedded computer. So, and the 5126 is dedicated to the RAMS process. So, how the RAMS analyses are built for and how their they are linked together to bring a safety demonstration for the whole system. Okay, next please. Okay, now the new je dirais, new actuality is that a new TS 50 or 701 is is released for some some European country, and this new TS is dedicated to cybersecurity, as we talked about in the already done presentation. Okay, this TS will bring some new certification, what is done by what we call EK, Independent Cybersecurity Assessment. Like the already organism that perform ESA Independent Safety Assessment, there is a new domain that is the EK, Independent Cybersecurity Assessment. And this new accredited organism can also bring some certificate for the VSTS. So it's a new, I think the new project of 2022 will need to be concerned by this TS and this EK certification. Next, please. Okay. The other fact is we are in a European country, and so there is now some technical specification for interoperability. Technical specification of interoperability is used for to the country to build systems that can be exchanged by between country, and so to perform a certification about to be sure that one system is able to talk with other one, there is some certification body that is not now called notified body, and these organisms are able to deliver certification to comply with that the system are able to interoperable with each one. Okay, but system that can be interoperability for in a European country, the different system can support also safety functionality. So the NOBO is not able to guarantee that is able to evaluate the safety aspect of this system, and for the safety aspect which link to interoperability, there is another notified body what is called assessment body. This assessment body will check that the system is safe regarding the level of required by the TSC. And then, okay, as there is some specificity for each country. There is some specific technical specificity to run the system in each country, and for this specificity, you have another organism that is the DBO, designated body, that is in charge to assessment of a project according to the national rule. So there is different organisms, but often are the same company that is able to handle all this aspect. Next. Okay. Now we have a specific organization for the critical system. Specific organization is that activities shall be independent from the design and the project. So conception, development, and design, safety and security conception are different from the verification and validation. Verification and validation can be independent or dependent depending on the skill level you require for. verification and validation are activities that will guarantee that the conception is safe. But the development, the design shall be designed for the safety. So design and design team and the conception team shall design their system for safety, and is not only the responsibility of the safety to demonstrate the safety of the system. Okay, at the end, all these activities shall be resumed, sum up in what we call a safety case. Safety case is the demonstration, is the written demonstration of all activities, all process has been clearly performed to demonstrate the safety of a system. And an independent safety assessor will bring his opinion and for the certification by an independent organism. Next, please. Okay. What kind of method we are using in safety and security? Well, most of the method relies on the same strategy, the assessment of the qualitative impact, the assessment of the likelihood, the frequency of occurrence of each event, and the evaluation of the impact of undesired events, like doing a cross matrix. We also perform V&V activities, that's safety and verification and validation activities, or cybersecurity and verification and validation activities. Well, when the design as performed is designed in safety and in cybersecurity and for protect the equipment, the V&V activities are done to verify that all the requirements are established correctly and they can be demonstrated through all the data furnished by the design. Okay, as we mentioned before, all the data will be collected through a unique document, which is a safety case and security case. Our safety case can be built if there is a system is not linked to security case, to cybersecurity aspect, but a security case can be also performed if there is only concern to security. Next, please. Okay. What we can find in the different standards linked to safety and to cybersecurity, here is only safety, but is the same strategy. You have some documentation or requirements and methodology that are allocated to each safety integrity level, or the document and the methodology or measure shall be done depending on the safety integrity level. As we can show, there is high recommended safety document or recommended design measure and so on, till mandatory that combination of measure and documentation shall be done. Next, please. Okay. Well, this is for just to underline that the safety cannot be done only by the safety teams. Okay, the management and the implication and the promotion is a key factor for the safety. Designing and the design team shall perform and design for safety, and the safety team will bring the proof that the safety is performed, not made the design for the safety. Okay. If the design team is not implied in the safety, well, what we saw is that the planning and the performance of a system are not very well. Next, please. Okay, this PowerPoint is to underline that seal level, which is concern the process to avoid what we call systematic failure. Systematic failure are failure linked to the process, that requirements may be not taken into account, or the requirements that are not clearly enhanced. And okay, seal process is not a THR. THR is how the probability of failure are assessed or evaluated. So we cannot perform a seal level and a THR independently. We have to perform all of us to reach a safety system. So the THR is evaluated on hardware, and most of the time the seal level is the process that is put in place to build the safety and develop the project. All activities, all activities, design, verification, and validation are need to comply with standard and safety requirement. So what we see in some projects, that some activities are not clearly done, like verification or validation. Some part of quality aspect are not performed. So at the end of the day, this activity or this will be mentioned by the certification, and so it will be some ECAR or some remarks from the certification that will be done at the certificate. So next one. In the new 5109, 29, the new Annex F is an informative one, but is dedicated to what is written like EPIC for FPGA, and so CPLD, and so programmable component. This is a new annex that defines a new process for this kind of component, programmable component, that okay, the program to develop this kind of component is equal to a development of software. So we find some, maybe the same document to be done for the programmation of this EPIC and as for software. Next one, please. For software, what we see is that a stack of different programming tools. Okay, what we see is that for the development of software, we have some now the use a lot of tools that bring some new rules to the process. So, and these tools need to be taken into account for safety point of view, because these tools can bring some errors in the programmation, and so these kind of tools need to be qualified, and some tests and some specification need to be done, or some certification need to be done for the use of this tool, and it has to be considered in the certification of a system. One other point is the interest of segregation. If you have the different software or seal level software, safety and non-safety, is very interesting to segregate these two types of software. Most of the time, non-safety software are linked to maintainability or to maintenance aspect. So the strategy will be more to use another microprocessor that support this kind of software than to mix the non-safety and non-safety software. So it's a very important cost of reduction because non-safety software are of a lot of functionality and a lot of bibliotheques that are used to build them. So if you don't segregate safety and non-safety software, you will have to perform all the analysis at the same level, the worst level, like SIL4 or SIL2, or to all the software. And a last table that is based on the aeronautic experience that show how much line of code can be produced depending on the safety level. Safety level like DAL-D is like SIL2 in railways, and DAL-A is like SIL-CAT in railways. And so we can see that the production of a line of code without or with experience and depending on the safety level is very low. If you see we want to perform a SIL4 development without experience you will see that you are just on the metric of 3 lines of code by day, which is very, very, very low. Okay, and next one, please. Okay, for software, a new amendment has come out, and we see that for this new amendment, the effort has been done to integrity, what we call integrity-based basic integrity. And for this level, the basic integrity level, the documentation has been lighted, and the production of the documentation need for basic integrity is now very low. Next, please. System safety case. Safety cases are split in three aspects. Three type of document. What we call generic product safety case, which is dedicated to a product. Generic application safety case, which address an application that is common to several projects, and specific application, what is address specific data for configuration. As we can see, there is different safety case for different strategy and for different products. And what is used to be able to use different products, safety certificate product, is that safety-related application condition. SRAC are export requirements that are used to indicate or to oblige the user to maintain safety continuously through the utilization of this product. Next one, please. Okay, and the last PPT is for indicate that safety case now interesting in the physical security and IT security. The IT security should be addressed by the TS that defines specific cyber security case, and the physical security is not addressed by the standards. Physical security is how you could log in and how you can access to the different aspects of software or the system. Okay, that's all. Thank you.
Well, thank you very much, Christophe. Any questions? That's a very hot topic. So, well, thank you again. Looks like the safety and the security, the cyber are all mixed together, and they are very accurate topics. Not to say, complex but very accurate topics. And thanks to the standardization here, well, and the committees, the different work groups, all this is getting clearer and clearer for our engineers. So let's invite to the stage a nice presentation from Mr. Eric Cariou and Mr. Christophe Bardoul about the Wi-Fi on board trains and how to communicate efficiently between the trains and the tracks.
Hi everyone, I'm Christophe Bardoul, Sales Director of Axis.
Hello everyone, thank you for attending to this presentation. I am Eric Cariou, CEO and co-founder of the company. Axis is a French company located near Paris. Our products are designed and manufactured in France. We are specialized in wireless communication for the railway industry, but we also supply products for the industry. We are a partner of Schneider Electric company.
Next slide, please.
The demand on onboard connectivity is increasing constantly and is driven by the needs in real-time CCTV surveillance in coaches for passenger safety, passenger entertainment, and HD video streaming. Our mission is to provide a reliable 500 megabits per second high-speed train-to-ground communication solution at 350 kilometers per hour. Our train-to-ground solution consists in access points deployed along the track side.
Access point there.
And 2 clients mounted on board the train for redundancy purpose with the VRRP protocol. Each client gives 250 megabits per second. The 2 clients totalize 500 megabits per second.
Yes. So what is roaming? So you have a Wi-Fi client that is connected to a Wi-Fi access point. And when the client connects to another access point, we call this roaming. So it's actually for the client changing from one access point to another. And in the Wi-Fi standard, the roaming occurs upon the loss of the access point. So the client loses the connection with the access point, then will start scanning and looking for another access point. So this is not very efficient, because by the time you lose the connection, you scan, you associate to, you find an access point eligible, you associate, and you start transferring data again, you lose packets. And it introduces as well latency. So it's not efficient at all, what is in the standard. So that's why all the manufacturers actually, they have their own roaming. And one of these method is the proactive roaming mono radio. That means the client doesn't wait for the loss of the AP or the access point to start scanning. So while it is transferring data, it stops to scan to look for another eligible access point, then transfer data again, and so on. And upon some criteria that are predefined, then the client will actually roam. It's better than the standard roaming, but still it's not optimized, because while the client is scanning, it does not transfer data. So it's not optimized as far as bandwidth is concerned. So that's why we looked a couple of years ago for a solution to optimize this roaming. And we developed what we call Connect Before Break technology, or CBB. So this is based, it requires 2 radios actually. So the principle is actually very easy to understand. So you have 2 radios. One is scanning while the other one is transferring data. So you don't lose any packets, actually. There's no latency. So the next slide I will explain. So while the first radio on the equipment is transferring data, the other one is scanning, looking for, it builds a list of eligible access points. And the best one of the list, then it will start the authentication with this access point and will associate to the access point. While the second radio is doing that, the first radio is still exchanging data with no interruption. And once, again, based on some settings, some predefined criteria, the scanning radio that is will actually connect to an access point, and then we'll send an ARP request, multicast, actually, to inform the network that now the packets needs to be sent to its MAC address. And then, so you have what we call convergence of the network. So this is what is explained here. So you have two radios or clients, if you prefer. So the radio one is exchanging data, so data transfer, while the second one is actually scanning, building its list of eligible access points. It will then associate. So the second radio will then associate to the best eligible access point. Then the network will converge with the ARP, with the GARP ARP, with the GARP. And the radio number 2 that was will then start exchanging data with the access point, with the new access point. And the first radio will start scanning. So alternatively, the two radios, one is scanning, the other one is exchanging data, and so on. Next slide.
Our solution are intensively tested in our lab, obviously. We use a Candela traffic generator and programmable RF attenuators to simulate the train in motion. This is what you can observe on this diagram. Next slide, please. Once test labs are completed, we start the field testing. As renting a high-speed train is unfortunately not possible for us, we use a supercar driving on an airport runway. This is what you can see on the picture. We do tests with the Audi R8 V10, able to reach a speed of 330 kilometers, sorry, which is quite close to the TGV cruise speed.
Yeah, sometimes we have a good time in doing our job, I mean, especially when we test like this on the field. So here, the process, so how does it work? So this is to actually, this is a train with some imagination. To simplify, we represented only the client at the front of the train, but you were shown before that there's a client at the front and a client at the back of the train. And on this Wi-Fi client, this is a rail box, by the way. Rail box, actually, this is our the product that is designed to be on board the trains. We've sold, we have like 20,000 of them installed in trains and metros all over the world, by the way. So this rail box has two radios. So first radio number 1, in this example, so is sending data to the ground network, an OCC, an operating control center on the ground. So sending data and receiving data from the ground, while the second radio number 2, so is scanning. Next slide, please. So radio 2 scanning, again building its list of eligible access points, finding the best access point in this list, and starting to authenticate and then associate to this access point. Again, while the radio 2 is doing that, radio 1 is still exchanging data, no problem, no packet loss, nothing. And upon some triggers, the radio 2 will decide actually to converge the network, so to send this gap on the network. And next slide. So the network will be on the ground will be informed that he has to send his packets to the MAC address of radio 2, and at that time, radio 1 will actually stop exchanging data and will start scanning. Okay, so now radio 1 is scanning, radio 2 is exchanging data, and so on. This is how it works. Next. We have actually a lot of parameters to decide when, at what time you need to roam. And these parameters actually, we introduce new parameters sometimes when we discovered on the field that the needs actually, it's very complex actually. The most difficult part when you on a project is to be able to set those parameters to have the best bandwidth and optimized connection.
It's because the behavior of RF is not predictable. And so we must do measurements in tunnels so to check it, and sometimes we have to make some change in the algorithm and add some parameters to correct it.
Yeah, it really depends on the environment actually. Tunnels, but also the orientation of the antennas, the gain of the antennas, and so on. So those parameters. So first, a list of basic parameters, roaming parameters, the list of channels to scan, of course, the time between two scans, the level of current AP above which no scanning is needed, meaning that if the signal level is good, there's no need to scan actually. Also, there are some conditions to select the candidate access point. Minimum, so it's the minimum signal actually to consider an access point as a candidate. Boost, this is the signal improvement that you want to see to consider the access point as a candidate as well. You don't want to roam just to gain 1 dB. The boost would be basically around 5 dBs, I mean, or something like that. Conditions to leave current access point for the candidate access point. So there's a leave threshold as well. Next, please. Yeah. We have also some. There's also some advanced parameters. Stability parameters. Sometimes the signal is actually moving up and down, and some hysteresis. So you don't want to actually you want to avoid this hysteresis. So there's stability parameters. So a threshold measurement tolerance. Candidate access point parameters. Maximum signal level to analyze or to consider an access point as a candidate. You would think, why a maximum? I mean, if the signal is high, there's no problem. No. If the signal is too high, you may have some problem in the receivers, the radio receivers. You can damage actually the radio receivers if the signal is too high. So that's why we have this parameter maximum. No return delay as well. You don't want to go back and forth from one access point to another. So this is also a parameter that is used. Conditions to leave the current access point for the candidate access point. So a minimum delay between two roamings, some signal thresholds as well. RSSI smoothing factor. Actually, there's you can give a weight on the beacon sent by the access point, and you do actually an average between the couple of beacons. This is actually this parameter to avoid to have some sudden change from one access point to another. You want to actually to have a signal that is a smooth, I mean, that is not doing this back and forth like this with sudden changes. You can roam also on the number of lost beacons. Next. And this is what is actually shown here on this diagram. On the top, the no scan zone. Why? Well, just to understand this diagram. So this is the signal on the current, on the pink. This is the signal with the current AP, called APA in this case, access point A. And the green one is the signal, level of signal with another access point that is named here access point B. So the current AP, the current access point A, when the signal is higher than the threshold here, you don't need to actually to scan. The signal is good, you don't need to scan. Then this is the time. You can start when you cross. Actually, you move like this. From the time moves like this, going on the right. Below a certain threshold, you can start scanning because the signal is not that good. Do you have some criteria? Actually, this is to say that as soon as you have a candidate access point that is eligible, you roam. This is we call this the need a roam. Okay. There's also a threshold. This one, the signal is not good at all. So even if you the signal is not good, you stay on the current access point because the candidate, the signal is not good as well. So, okay, next. So the performance achieved, so that we achieved by the test and also that we achieved on the field, because CBB is used actually on some metros in Paris, for example, on some metro lines in Paris. So it's a 0.1% of packet lost. So at 350 kilometers per hour, so this is our test. This is not the metros, of course, because 350 kilometers, it's quite fast. And what is interesting is that this is not dependent on speed and not dependent as well on the throughput.
Okay, as you can observe, building a wireless cable between the trackside and the train in motion is not trivial. So this is the reason why we had to develop this algorithm, which is pretty complex and with a lot of parameters. But this is a recipe to have something working very fine. It is actually deployed in Doha for on the metro of in Qatar for the metro of Doha and the tramway of Lusail. In perspective of the football soccer next year. It is also deployed on the metro of Panama and finally on line 4 and 14 of the Grand Paris Metro with French RATP and Atos Nokia.
Well, thank you. Thank you very much for the presentation. So, well, thanks again for the presentation, and maybe a quick question. So why are you not using the 5G like everyone? No, not like everyone on the railway business?
5G is very interesting when you are in open air or in the campaign, but for tunnels it's not possible. And the most of the business we do is for metro. And so 5G is not available in metro. So this is the reason why we use wireless infrastructure deployed on the trackside with one access point each 300 meters. So the reason for this distance of 300 meters is because we must achieve redundancy, trackside redundancy. It means that the moving client on board the train must be able to see at least 2 access points. So if one fails, the system continue working, so we offer redundancy. So 5G for a tunnel is not good. But we will introduce Q1 2022 or a new range of products with Wi-Fi 6, Wi-Fi 11AX, and 5G. So in the same case, same box, same presentation of the product.
Yes, and just also complement to this answer. 5G, unless you use a private 5G network, if you use the public network, you don't have control of this network. So this is something that is sometimes embarrassing. So unlike a Wi-Fi network, okay, you have an investment that is higher at the beginning, but you really control this network.
Okay, well, thank you for this explanation. And well, if it's only for the metros or mainly for the metros, we hope that we'll get such technologies on board the next Line 3 of Toulouse Metro, which has been awarded to Alstom as a major rolling stock company here, who is going to provide us the next generation of metro train cars. Thanks again. So we will move to the next presentation. I would like to invite Mr. Petro to join in. Mr. Petro from the company Spheria. Thanks again.
Good afternoon. Thank you very much for inviting us in this conference. In this presentation, we'll talk about rapid prototyping solution developed by Spheria, its capabilities, and how it can be adapted to become a serial product. So, wow. Can you go back for once? Thank you very much. First, quick introduction about me. I'm Florent Petro, in charge of the research and technologies for Spheria. And concerning Spheria, we are a company specialized in test system solutions, used mainly in the aerospace industry, but also in the railway industry. Next slide, please. So why this presentation and why this product? First of all, it's we have developed this product in order to address new developments concerning the predictive maintenance and autonomous train, and also in order to introduce and adapt those new technologies inside railway industry, and how to reduce time between this technology and how we can use it inside the real environment. So for that, next slide please, we have developed a solution that is compliant with the railway standards in terms of environment conditions, by providing a platform fully compliant with the environment standards, and also in order to assist the end user, we have provided inside the platform a full environment allowing to integrate directly MBSE-based model developed by various simulation environments, for example, directly inside the embedded software. That's allowed to directly get an idea, a new technology, for example, a new RF solution, geolocalization technology, and adapt it, develop a software by using traditional or new MBSE development solution, and embedded it directly inside the railway platform, and very quickly, with a very short time, put it directly inside a train, for example, and check its behavior in real condition. Moreover, we have added various user interface allowing easier operation and maintenance operation, which are very important when we are prototyping a new technology or testing a new software, new system inside an embedded system. So we have provided a web server interface, for example, that is directly accessible by using the equipment Ethernet connection, or for example a Wi-Fi connection by using a laptop next to the embedded equipment. And moreover, we also have provided a full toolbox allowing post-processing of data acquired by the embedded system. This kind of equipment has been developed for a very wide range of applications. So it can be used for example, system health monitoring, but also to integrate LTE communication to a ground center. We can embed also GNSS navigation inside the equipment and provide many parameters provided by GNSS constellation directly inside a behavior model. We also provide various systems to record data directly inside the equipment or to push data inside the cloud environment, and vibration, odometry, and acceleration system allowing to make some artificial intelligence experimentation in real conditions. So for this activity, we have an hardware solution embedding first of all processing unit very performant at the state of the art with based on the Zinc UltraScale Plus solution from Xilinx, allowing to embed processing unit based on the IRM Cortex i53 and an FPGA allowing to develop very high-speed processing calculations, very important for artificial intelligence or also for vibration acoustic analysis. The last part of the processing system is that we can also embed deep neural network accelerators based on the Intel Movidius solution, which allow directly to embed artificial deep neural network calculation and inference directly inside the embedded equipment, and reduce, for example, the data stored for example, post-processing. We can reduce the data that will be useful and interesting to store inside the equipment. Concerning the external input-output and sensors, in the base solution, we provide various sensors such as GNSS, EMU, temperature, humidity, directly inside the equipment that allow to provide more information in case of prototyping about the environment context when we store and we measure data of our new technology. And we provide the connectivity to use Ethernet connection, various serial link, and also wireless connection such as Wi-Fi or LTE for the most important technologies used currently. And also, in order to interact with the rail, the train, we provide discrete, analog, and relays directly inside the equipment in order to interact with the rest of the world. Also, this hardware and this electronic can be embedded inside various form factors. We have developed different form factors in order to be integrated in different environments with different options and different functionalities. For example, in the bottom we can get a small box embedding Ethernet connection and various discrete input-outputs, and which is compatible with many trains and voltage that we can see in train conditions. And on the top, it's middle top, it's an equipment allowing to do a GNSS localization, but also LTE connection in real time, and embedding directly the antenna on top of the box, which allow to use this equipment without doing a lot of engineering on the cable on the cable circulation inside the train. And next one, please. Thank you. So this is this equipment first is based on a solution allowing to work inside a simulation environment, develop an application inside, for example, MATLAB Simulink, and put the various input-output that are provided by the equipment, developed a software inside a simulation environment, and once this software has been fully tested in full simulation, it is possible to take it and directly embed it inside the real equipment and test it in real condition. We provide inside the equipment every calculation required to translate the physical signal to engineering values. Oops. And we provide in this equipment a maintenance interface, allowing, for example, to visualize in real time important values that we want to monitor. That's a very important thing when we are installing the product inside the train. And we also provide interfaces allowing to quickly update the behavior of the equipment directly without removing it from the train, updating a new firmware and put it again in the train. We can directly update the firmware by using a Wi-Fi connection, for example, and check if it's working and very quickly update it. It's a very interesting features for rapid prototyping and to allow incremental development of the behavior of the equipment. Next one. And the last one, we provide to the end user various user interface, for example, a map allowing to see where the equipment is located, and also a very high-level programming language allowing to define very easy calculation in order to make a dashboard of the more important information that we want to see when we are trying a new prototype inside the system. Thank you very much.
Well, thank you again for your presentation. It was the last of the day, so thanks again. Any questions, maybe? Well, and maybe one question. So how can you help rolling stock manufacturers and system integrators with your solutions?
So we can help manufacturers by providing a solution allowing to very quickly test a new software inside an already qualified equipment. And so moving a little bit from a V-cycle development with a very long time between the idea to the test inside a real environment, to an incremental development where we can put directly inside non-ready environment qualified equipment to the new software.
Okay, well, thank you again very much for this explanation, and this is going to finish our nice 2 days of conferences. So we'll invite Mr. Paolo to join us so we can have maybe the final conclusions and the word of the manager of the ICT for Railways event. And then, in the meantime, I will invite all our speakers from this afternoon to join in here on the stage. So Didier, Sophie, Sébastien, Christophe et Eric. Florent, vous allez revenir. So we'd like to invite you to join here, just to receive a little present, to make a nice little photograph. And then Paolo will be able to... yes, 2 meters.
Oula. Vous avez le droit qu'à une, vous t'intéresse.
And also, I would like to
Merci.
give my all thanks to these nice little sponsors. So, of course, Ferrocampus as a platinum sponsor, so with whom we could not have this event, let's say. And Ferrocampus was also assisted by the gold sponsors Unife, so the European rail industry, XBlue, as well as ClearSea, and also Lear Automation, Erasm, Axis, and Spheria as the silver sponsors. And to finish, VDS Rail, Mitsubishi Electric Research Lab, and the Alstom Corporation, who made this event to be a real success, without forgetting the media partner, B2B Rail. B2B Rail is, let's say, making reports, making lots of information available on the social networks and in their magazines, so the only rail specialized company and agency to promote the rail industry. Thank you to B2B Rail.
Thank you.
Paolo?
All right.
So, we are at the end of this workshop. I hope it was interesting for all of you. It seems strange to me each time at the end of a workshop like this to think that after so many months of work, preparation, meetings and so on, in less than 2 days everything is finished. But this is the life. I hope very much that it was interesting, and I think that finally we kept the promise I made yesterday morning to give you a quite comprehensive and rather detailed overview of how ICT is contributing to shaping the future of the railway sector, with the essential contribution of standardization in good harmony with regulations and with research. And of course, finally, with the important work which is done within railway industries and organizations. So thank you very much again for having been here, and I hope to see most of you at the next edition of ICT for Railways, which will be in 2023, because this event is every other year. We don't know yet where, we don't know yet exactly when, will be some time after summer in 2023, but you will receive an information that the new edition is coming. So thank you again, and have a nice trip back to your home.
Thank you, Paolo. Thank you, Paolo, for supporting this ICT for Railway Events 2021. Let's bet that maybe we'll go to Spain in 2 years. It would be a very nice place to be, of course. So we count on you to come again. And well, we would like also to give our special thanks to the Cluster Totem, which is a regional cluster of companies gathering all the industry from the railway domain, of course, mixed with the automotive, the ecosystems, and the naval maritime industries. So thanks again to Cluster Totem, and thanks again to the company hosting us here, Stade Toulousain, which is quite a nice venue, sporting venue, slightly different from the context of our companies and our industry. Thanks again to everybody. Thanks. Merci.
When you're here, you'll discover
Benoit?
this. You'll relish
Benoit?
in this, and this too. And you'll be amazed by this. This artwork will still be here. These landmarks too. You'll get around like them. Or maybe like them. You'll vibe with people like this. And we'll share all that. There you go. When you get here, we'll be waiting.